Welcome to Ask and Learn.
All right, for this problem, so we have two processes. The first one is the gas is heated, and the first one is actually isothermal process because the temperature is fixed. And the second process is so we have the constant pressure. Yeah. So okay, the part is we want to find out we want to sketch the PV diagram. So as I mentioned, the first process is isothermal. This is the P, this is the V. Isothermal basically is just the curve. And the second process is first one we need to don't forget the direction of this process. We know that the initial volume is 1.5 liters, and the pressure is 10 to the 5th Pascal, and the final pressure is lower, so basically it's pointing to the right. And second process is actually constant pressure, so it should be a horizontal line. And it just returned to the original volume of 1.5 liters, so basically it's pointing to the left, and it is a horizontal line. Okay. And you can also label that these 2 points, they have the same volume, which is 1.5 liters. And also you can label this pressure and this pressure. So this pressure is 2.5 times 10 to the 4th Pascal, and this one is 10 to the 5th Pascal. Okay. For part B, we want to find out the volume of the gas at the end of first process, that is this point. We find the volume at this point. So to do that, we need to look at the state equation, PV equal to nRT. We know that in this process, in the first process, N is constant, R is constant, and T is constant. So basically, we have PI. Suppose this is state 1, 2, and 3. Okay, so P1, the pressure at state 1, times V1 equal to P2 times V2. And then we obtain the V2, the volume at this state is V1 times P1 over P2. All right. So V1 is given as 1.5 liters, and P1 is here. This is P2. So we obtain the V2 is 6 liters finally. For part C, we want to find the work in the two processes. For the process 1 to 2, for the first process 1 to 2, the work by definition is P dV, right? And P is, because this is isothermal process, P is simply nRT over V dV. And nRT is constant, so we can move it out of this integral. nRT, and this integral will give us log V2 over V1. All right, and this log is a natural log. So we plug in the values. nRT basically just equal to P1 times V1, and we already know the P1 V1, so it also equal to P1 V1 times log V2 over V1. All right. So we just plug in the values of P1 V1 and V2. So we obtain the final result is 207.9 joules. This is for the first process. The second process, I write here, but there is not much room for me. The second process from 2 to 3. as you can see, this is the constant pressure. So the expression for the work is simply P2 times V3 minus V2. Okay, and just plug in the values. And don't forget that you need to transfer this later into meters cubed to transfer this into the standard unit. And the value I found is negative 112.5 joules. All right. So these are the two works done in the two processes. And for part D, we want to, let's see. So we want to know what we need to do to return this gas to the initial state. So this is the final state. This is the final state, and this is the initial state. Basically, we want to transfer from this point to this point. So because these two states, they have the same volume, so the only thing we need to do is just increase the pressure. So basically, you can see that okay, we need to fix the volume, like fix the container and add some heat into this gas, so that the pressure is added into up to this state one. So that is basically just you just express like fix. Sorry, you just need to fix V, fix the volume, and add pressure, and then it will just come back to the initial state. Yeah, that's it.